Hello everyone, welcome back to my channel. I am Jitesh Powankar, and in today's episode we will build an agent that will resolve image pullback error. In this episode we will use a Llama 3 via Olama. We are using Kubernetes Python client for direct API interaction, and this is the agentic AI design pattern for autonomous healing. We generally get this type of error because of wrong image tag, sometimes image not found, we made some typo in the repository name, or sometime it is the authentication issue. Traditionally, engineer debug this issue manually, but in this episode, we will build an AI agent that can detect and fix it automatically. How our agent works? So it will observe the system, it will analyze, and based on that analysis, it will take the decision and act accordingly. Once it is acted, we can verify it is fixed the issue or not. This is the workflow. So we have Kubernetes cluster and we are deploying one pod that will get into the image pullback error. We have written a AI controller in Python that continuously check the status of the pod. If it will detect the failure, then it will send that context to the Llama 3. Our LLM take the decision and it will patch the deployment, and after that it will rolling restart the deployment, and our pod should come in the healthy state. This is the architecture of your Kubernetes cluster, and we have this image pullback event. Now we have controller, we have this LLM running in our system with the help of Olama, and it will patch the deployment. In the tech stack, as I already discussed, we are using Kubernetes. Now we have using Python Kubernetes client instead of using kubectl CLI. We are using Olama for running a local LLM runtime, and we are using Llama 3, and this is our agenting AI. So this is the project structure we have. We have agent.py, config, observer, actions, LLM brain, and we have written the prompt. And this is our bad image.yaml file to deploy pod in the Kubernetes. So if you come here, this is our agent where we have observer, LLM brain, action, config, and here we have given the prompt. If you come to this prompt, here we have specified like you are a Kubernetes reliability agent. If image tag is invalid or not found, then fix image tag. And if issue seems authentication related, then escalate to human. And again come back to agent. Then if you come here, so this is our controller. We are running this controller. And if you come here, so we will modify. So its agent is started, and then we will check the we will find the namespace. So if you come here, here we are specifying the namespace, and we are calling this. Here we are using Kubernetes library instead of using kubectl command. And here this is here where we are loading the kubeconfig, and we are creating the client. So if you it will list down all the pods in this namespace, and it will iterate over the all those pods, and it will check the status. And if you come here, so if you it will find image pullback or error image pull, then it will send, it will append the error. And again if you come back here, then if there is no failure, then we can directly print no image pull error, and then again it will check the uh, control could keep running to check the status of the pod. Now if we have failure, then it will notify failure detected, and now we have the context that we have get from here, and we will send this context to our LLM. So here now we have prompt and context. We are sending this our context. So here, if you come here, this is our brain. So now, if you see, this is our LLM, and here we are sending this Llama URL, and this is a model, and we are sending this message, prompt and context, and it will take the decision on the prompt. Once it take the decision, it will then notify what the decision it is, and if decision is fixed image tag, it will fix the Kubernetes deployment. And now once it's fixed, then it will continuously check the status of the pod. And here if you see the config, here we have specified the prod namespace. This is our app name, deployment name, and model which we are using, and this is the check interval. So in every 10 seconds it will check the status of the container, and these are the allow actions we have specified. And also we have specified the fallback image as a correct image. So now let's start with the demo. First we will clone our repo, and git clone. So now we have cloned this repo. Now let's go to this directory. Here you can see that your agent.py config, our actions, LLM brain, observer, and prompt we have. Now if you come here, we have steps to run this demo. So first we will create the environment. First we will create the Python. Okay. Now we will activate this environment. Now let's install our library. We need Kubernetes and request library. So we will install this library. So library is installing. Okay, installed successfully. And now let's clear. And now we will run Olama. First we will pull the Olama. And yes, so it was quick for me because I already pulled this model. And if you come here, then we will start. So I already started, that's why it is saying already in use. So I can also verify this by running this command. Olama is running. So if you haven't watched my Olama episode, then please watch it. How to run, where we have explained how you can run a local LLM on your system using Olama. So now our system, our prerequisite is ready. Now let's create our namespace first. So first we will create our namespace. Okay, now namespace is created, and now we will now let's deploy our pod. That pod will get into the image pullback error. Now let's go to the Kubernetes where we have our file. So this is bat image.yaml. Now let's run this command. So yes, deployment is created. Okay, now what we can do, we will check get pods -n and our namespace. So here you can see we are getting this error image pullback. Okay, again let's check. Now it is saying we are getting image pullback error. Now if you check the image tag, so if you take the deploy -o and YAML, so if you come here in the container sec, we are using Nginx and wrong tag. Because of this, it is getting in the image pullback error. Now let's run our agent. Okay, so this is the command. So before that, I will clear the screen. Okay. And now let's run our agent. Let's come back to the previous directory. Here you can ls and here you can agent.py. Okay, so now we will run this command. So it should run and fix our issue. So you can see like image pullback AI agent started, and you can see here like it is able to detect this image pullback error and it is image tag wrong tag. Okay, now LLM take the decision to fix the image tag and it fixed the image. So here you can see. Now let's go here, and if you see kubectl get pods in prod, you will be able to see the pod is running now. Okay, you can see 24 seconds ago it pod started, and now if you check the deployment, deploy on YAML, then if you come here, then it should be the correct tag in image. Okay, so if you come here to the container, so here you can see Nginx latest tag. So we have correct version, correct image tag now, and now pod is running. So if you can check here like pod is running perfectly, there is no error with the pod. So if you come here to the agent, so you can see like we have running this agent in controller loop. So it is continuously check in every 10 seconds, it will check the status of the container. Now we don't have any error. Because of that, we are getting this log like no image pull error found. So this is the how our agent will fix our issue in the production. Now let's come back to our repo. So if you come here, so this is the action we are taking. So fix image, the replace incorrect tag, or maybe escalate to human for auth or unknown issues. And so this is the key learning from our demo. So we are moving from manual debugging to automated healing. We are using LLM to take a decision, and it is the controller based AI system. So it will continuously check the pod status. And now we are using Kubernetes Python client instead of using kubectl CLI. And if you following this series, so we have created AI incident resolution agent, then we have created a memory killed healing agent, then CPU throttling healing agent, and last episode we have covered failure healing agent. Now in this episode we have created image pullback healing agent. So if you are not watched my previous video, then I highly recommend first watch all this episode where you will get the idea how you can run local LLM with the help of Olama. And then if you like this project, then you can start this repo or subscribe to my YouTube channel and share feedback. That's it for this demo. And if you have any question, then you can comment in the comment section. Thank you.